Welcome to the Advanced Companion Drone System, or simply ACDS. In this video, we'll integrate ACDS into an existing Unreal Engine project. For this tutorial, we'll use Epic Games' game animation sample as our starting point. Before we begin, make sure you've already downloaded ACDS and added it to your project. Once installed, you'll find the ACDS folder inside your project's content folder. This folder contains all the assets, blueprints, and components that make up the system. To perform the basic integration, we'll only need two classes, your PlayerController and your PlayerPawn. In this example, we'll use the implementations already included in the game animation sample project. Let's begin with the PlayerController. The first step is to add the companion control component. This component is responsible for initializing the drone input system and registering the input context used to control the companion. Although you can initialize it whenever you prefer, I recommend doing it during the Begin Play event of the PlayerController. Next, select the included IA drone control input action and pass the current PlayerController as the self-reference. Now it's time to initialize the component. Implement the onPossessed event. Using the possessed pawn as the target, call references from companion owner. This function retrieves two important references, the player's skeletal mesh and the undeployed static mesh used to visually represent the companion while it's docked. If your project supports multiplayer, this initialization must also run on every client. For that reason, I recommend promoting the possessed pawn output to a replicated variable and enabling rep notify. Next, retrieve the companion control component and call the function references to control companion. Pass the references obtained from the previous function, along with the possessed pawn reference. If you're using a HUD to display companion information, pass the HUD reference through this function as well. Since this initialization must run on every client, move these nodes into the possessed pawn rep notify function. Once that's done, compile, save, and we're finished with the PlayerController. Now let's move to the PlayerPawn. Once again, we'll use the implementation included in the game animation sample project. To visualize whether the companion is docked or deployed, we'll create a static mesh component. Name it Drone Static Mesh. Assign the undeployed drone mesh, adjust its position, and disable collision. Next, go to the event graph. The first thing we need is to implement the interface that allows the PlayerPawn to communicate with the rest of ACDS. Open Class Settings. Locate the Implemented Interfaces section. Search for CompanionLink and add it. Once added, new interface functions will appear inside the My Blueprint panel. We'll focus on the PlayerPawn category. Implement these two interface events, Companion Visual State and Receive Companion Core Component. The Receive Companion Core Component event provides a reference to the active Companion Core component, allowing your character to interact directly with the currently deployed companion whenever needed. Promote the output to a variable. If your game is multiplayer, remember to replicate this variable as well. The Companion Visual State event tells your character when the docked drone mesh should be visible. Retrieve the drone's static mesh component and update its visibility using the event output. If you're working in multiplayer, promote the output to a replicated variable, enable rep notify, and perform the visibility update inside the rep notify function. Earlier, the PlayerController requested several references from the PlayerPawn. Now we'll provide them. Open the References from Companion Owner interface function. Connect the character mesh to the mesh output, and connect the drone static mesh component to the static mesh output. The final step inside the PlayerPawn is providing the Companion preset. Implement the Companion Preset interface function. This function returns the preset that ACDS will use whenever the companion is deployed. Promote the output to a variable. How this variable is assigned depends entirely on your own game. For reference, you can take a look at the implementation included in the ACDS demo project. In this tutorial, we'll simply assign one of the included presets manually. Compile, save, and the PlayerPawn setup is complete. Now return to your level. Before testing, make sure you've added a NavMeshBoundsVolume. The companion relies on Unreal's navigation system, so this step is required for movement to work correctly. Once everything is ready, press play, and press F to deploy the companion. There's one final adjustment we should make to adjust the undeployed drone static mesh. Open your character's skeletal mesh. Create a socket on the bone where you'd like the drone to be attached. You can preview the drone mesh while adjusting the socket position to make alignment easier. Finally, return to the character blueprint, clear the current transform of the static mesh component, attach it to the newly created socket, compile, and save. The undeployed drone should now appear correctly attached to your character. And that's it. Your project is now fully integrated with the advanced companion drone system. From this point, you only need to configure your companion presets, define which gameplay classes each preset can interact with, and configure your NPCs. You're now ready to start building your own companion experience.